Yeah. All right, so in 5C, how would you read this one right here? Cosecant, what'd you say in between cosecant and inverse sine? Of or times? What'd you say? Of. Is that what you said? Yeah. It's cosecant of, not cosecant times. Right, because it's not, there is no input. It's just cosecant, so then this is inside the cosecant, and then it's inverse sine of 3/5. So this is composition. Are cosecant and inverse sine inverses of each other? No, so it's not just going to do itself. So the inverse sine of 3/5 is going to give us some angle theta in the PVR, but theta is not our final product. We want to turn around and take the cosecant then of that theta. So this is kind of like a two's clues problem. What does a capital S mean? One value, right? It's going to be the function inverse sine. Anyone know what the answer is without drawing a picture? I want the cosecant ratio of the angle whose sine ratio is 3/5. That's another way to read it. It would have to be 5/3, wouldn't it? Yeah. Because how are the cosecant and sine ratios related? What? Starts with R and rhymes with reciprocal. Reciprocal. Good. Yeah. Now you could, if you want, draw the picture. If we take the inverse sine of a positive ratio 3/5, in which quadrant will theta live? Quadrant 1. Good. That's the positive ratio PVR. So that would be theta. If you drop the perp, you would have 3, you would have 5. This ends up being 4. But now you have all 6, or all 3 sides, you have all 6 ratios. You want the cosecant. Cosecant is R over Y, so you could do it that way as well. So sometimes it's just kind of nicer to make connections along the way as you go. All right, so let's go ahead and look at this asterisk. In general, when we're finding angles in unspecified intervals, from now on, in general, when we're finding angles in unspecified intervals, we're assuming that we're going to be finding the angles of the inverse trig function. In other words, I don't necessarily have to use the capital letter anymore, okay? If you are not given an interval, then assume it's just the one solution at this point. Okay, so here's something in a box. It's not donuts, but just as good maybe. Maybe a little healthier. Sine of arc sine of x, how are those related? Sine and arc sine, how are they related? They're inverses. So if we start with x, we should end up with x, right? Because inverse functions undo each other. Is that always the case? Well, maybe. What does x represent, an angle or a ratio? It's a ratio, yeah. So if we start with a legal ratio, then taking the inverse sine of that legal ratio is going to give us an angle in the PVR, and then I turn around and take the sine of that same angle, it should be the exact same thing, right? So whenever you're taking the sine of an inverse sine of x, where x is a ratio, they will automatically undo each other. It will become x as long as the ratio is legal. And what are the legal ratios? -1 and 1. So what would sine of arc sine of 4/9 be? 4/9, right? 4/9. What would sine of arc sine of 9/4 be? 9/4? Yeah, 9/4 is too many. Yeah. So sine of arc sine of 9/4 would be D and E. Why? Because 9/4 is not between -1 and 1. So as long as you're starting with a legal ratio, sine of arc sine is going to undo each other, and it's going to just be what you started with. Now, if you do it the other way around, because in general, composition is commutative. 2 steps to the left, 2 steps to the right, is the same as 2 to the right and 2 to the left. But you got to be a little bit careful when it's in this version. If we start with an x that represents a what in this case? Angle or ratio? This is an angle. Yeah. X in this case is an angle because it follows the sine function. So if we start with an angle, we have to be careful. Arc sine of an angle will be the angle that you started with. They will undo each other. But remember, the last thing that we're doing is taking the arc sine of that ratio, whose sine is that angle. And that means that our angle has to be where? In the PVR. So if you start with an angle x, that is not in the PVR, it's not just going to undo itself, okay? I used that one for a while too. The angle though is going to be. I'm sorry, I lost track of that. Okay, so if you start with an angle X and it's not in the PVR, it is not going to be D and E, because what's the domain of sine? The domain of sine is all real numbers. So if you start with an angle that's not in the PVR, it's not going to be the angle itself. It'll be a different angle. We have to find it. But it will cancel out if you do happen to start with an angle that is in the PVR, which remember for sine, arc sine is negative pi s to pi halves. All right, let us try it out. Example 6, evaluate the following compositions without a calculator. Oh my goodness. Sine of, inverse sine of, that number. All right, so this number here is an angle or a ratio? It's a ratio. Is it a legal ratio? Yes. So the sine of the inverse sine, do they undo each other? Yes, they undo each other. If we start with a ratio, we're going to end with a ratio, and if it's a legal ratio, it's that same ratio. Okay, so that one was easy. All right, inverse sine of pi fourths. Inverse sine of pi fourths. We're starting with what, an angle or a ratio? An angle. These are inverses of each other's. Will the answer be pi fourths? Well, let's see. Is pi fourths in the PVR? Is it in quadrant 1 or 4? Yes. So the answer is pi fourths. Now, when in doubt, if you have the opportunity, you could work it out. What is sine of pi fourths? Square root of 2 over 2. So if you want to replace that with square root of 2 over 2, now you have the inverse sine of square root of 2 over 2. And very similar to the warm-up now, we're looking for the angle in quadrant 1, where sine is positive, whose sine is square root of 2 over 2, which, of course, is pi fourths. But sometimes, again, if you understand the relation and what you're starting with, it's just a little faster. Reciprocal? No. That's not the reciprocal. That's the inverse. And the whole point of this is that it's not always going to cancel itself out. Only sometimes. Okay? Why did it cancel itself out in this case? Because pi fourths, the angle we started with, is already in the PVR for arc sine. In other words, it's already in quadrants 1 or 4. Now, let's look at the very next one. Arc sine of 3 pi fourths. We're starting with an angle. Is the answer just going to be 3 pi fourths? Because this makes a great multiple choice question. And that would be an answer choice, but that's not right. So why does this one not just cancel out? Because 3 pi fourths is, yeah, it's in quadrant 2. It's over here. It's not in the PVR. So this one is not going to be D and E. We just have to figure out what the angle is going to be. So here's one way to do it. What is the other angle that happens to be in the PVR that also has the same sine value as 3 pi fourths? Is sine positive or negative in quadrant 2? Positive. What's the other quadrant in the PVR where sine is positive? 1. So we're looking for the quadrant 1 angle with the same sine as 3 pi fourths. It should be 1 pi fourths. So that's one way to do it. The other way to do it, in this case, because we actually know what sine 3 pi fourths is to work it out. But we're not always going to do that. We're not always going to know it. Sine of 3 pi fourths is positive square root of 2 over 2. And now arc sine of square root of 2 over 2, just like we did in the previous problem, is actually pi fourths. So here's what you do. You figure out where the angle that you're given lives. In this case, quadrant 2. Quadrant 2 is outside the PVR. The angle you want is going to be the exact same as the other angle, which means it's going to have the same reference angle. So if it's a pi fourths reference angle in quadrant 2, it's now going to be a pi fourths reference angle in one of the other two quadrants. Now you look for the sine. Sine is positive in quadrant 2, so therefore sine is also positive, in this case, in quadrant 1. And, of course, the reference angles are the same, so now it's your pi fourths reference angle in quadrant 1. Case in point, let's look at this guy here. Arc sine of 13 pi tenths. William, is this one just 13 pi tenths? No. Good. Even though these are inverses. Because where does 13 pi tenths live? Yes. Quadrant 3, that is 10 pi tenths. And then we go 3 more, we're over here. So what's your reference angle? 3 pi tenths. We've gone 3 pi tenths past 10 pi tenths, which is pi. So in that quadrant, is sine positive or negative? Negative. I want to pick then the angle that has the same sine value as 13 pi tenths, but it has to be in either quadrants 1 or 4. So which of those two quadrants in the PVR is sine also negative? Quadrant 4. So I want to get to the angle in quadrant 4 by going clockwise by the same reference angle amount, which we said was what? 3 pi tenths. So to rotate clockwise 3 pi tenths, we get what? Negative 3 pi tenths. Excellent. For sine, it should always be plus or minus the reference angle. Why? Right, because the PVR is quadrants 1 or 4, which means it's always going to be some kind of acute angle. Right. If you can find the reference angle for sine, then it's either going to be plus or minus the reference angle. Yeah. All right, do this one on your own. What'd you get? I didn't wait long enough, sorry. Now what? What'd you get? 4/3? Makes a good answer choice on the test, that's for sure. Yeah, now we're starting not with an angle, but a ratio. How do we know that's a ratio? It follows inverse sine, okay? Is it a legal ratio? No. So it's D and E. Yay! Good. We can build on that. Yes, as you said. All right. Any questions on those? It starts easy, like, oh, I get that, and now it's like, ooh, it gets more interesting. Thank goodness. I hate coming to school and being bored. All right, example 7. Draw a couple of cycles of cosine. Okay, so here's what we're going to do. We're going to develop the inverse cosine function now, and we're going to do it in a similar fashion to what we did for our inverse sine. How did we sketch cosine? What mnemonic? Chala. So if f of x is cosine of x, it's chala, so put your critical values down. We have 2 pi, pi halves, 3 pi halves, 0, and then negative pi halves, negative pi, negative 3 pi halves. So it looks good. All right. Is cosine even, odd, or neither? Just throw that in there. It's even, just like its reciprocal function, secant. Okay. So cosine goes up here to 1, comes down here to negative 1. So it's going to be high axis, low axis, high. And notice I'm doing it this time crazy. I'm not drawing my dots, my critical values. Okay, so what we're trying to do now is see what the inverse of cosine will look like. Is cosine 1 to 1? Is cosine 1 to 1? No, it's not. How do you know it's not 1 to 1? What test do you do? Horizontal line test. Does it pass the horizontal line test? It does not. Okay, so what we want to do is very similar to what we did with sine. We want to restrict this domain to, first of all, the 3 criteria were a 1-to-1 interval. But I don't want to just do random intervals like from 0 to pi halves. That little interval there from 0 to pi halves would be 1 to 1. We want to then, second criteria, include a 1-to-1 interval that includes all the y values that cosine takes on, which would be from negative 1 to 1. And then the third criteria, we want it to be convenient. Yeah. So what is the most convenient 1-to-1 interval that includes all the y values from negative 1 to 1? 0 to pi. Now, what about the interval from negative pi to 0? It is just as convenient, isn't it? It's the exact same distance away. I don't like negatives. Right, that's what most people say. That's what they actually said at the meeting. Someone brought that up, and the whole group said, we don't like negatives. And so that guy was outvoted for that very reason. So this is the interval that everyone agrees to use, okay? We're going to use then the interval from 0 to pi. Now, I will do the same thing. I will highlight on this low-tech paper model the red region from 0 to pi on the graph of cosine. And notice, where am I grabbing this landscaped piece of paper? On the corners that are y equals x, because that becomes the magical mirror across which we reflect this graph to get the graph of inverse or arc cosine. And notice it snakes left and right across the y-axis. But if you just look at the red piece through there, I don't know if you can see it. Yeah, it shows it pretty well. You get the graph of arc cosine, the function. So let's see what that looks like. We'll give it its own graph. It looks like this. Right, do it again. Here's the graph of zoop, zoop, zoop. So it's a what type function, increasing or decreasing? It's a decreasing function. Arc sine was increasing. Now, just like on the arc sine graph, the x information and the y information all interchange. So the old range of cosine was -1 to 1. It now becomes the domain. So this one goes left and right from -1 to 1. And that's the domain, right? We input any ratio between -1 and 1. The old domain that we restricted now becomes the principal value range for arc cosine. And we restricted it from where to where? 0 to pi. Good. So that is now the range of the PVR, the principal value range. And of course, we have pi halves in the middle there. So here's your function, f of x equals either inverse cosine of x, or by the same token for sine, we can replace the inverse with arc cosine. And it has two c's. Arc cosine has two c's, like accentuate or accurate. All right, let's talk about some features like the domain. We've already talked about it. The domain is what? -1 to 1, and those are angles or ratios? Ratios, yeah. So same as arc sine, right? We have to have a legal ratio of between -1 and 1. The range, or the PVR, I'll write it as PVR, principal value range, is 0 to pi. Now, it's always helpful to think about it in terms of the unit circle as well, because that's where we originally learned to take care of these things. Arc sine was quadrants 1 and 4. That was the half moon. Arc cosine is going to be from 0 over here to pi. So this is not the half moon. This is what I call the sun on the horizon. Okay, the sun on the horizon. So here's the idea. If you ever take the inverse cosine of a positive ratio, that's not -1 or 1, those are the extremes, you're going to end up just like arc sine with a positive acute angle, right? Positive ratio, positive acute angle. But it differs when you have a negative ratio. For inverse sine, a negative ratio gave you a negative acute angle, and in this case, a negative ratio for inverse cosine is going to give you a positive, what? Obtuse angle. A positive obtuse angle. It's going to give you a quadrant 2 angle. Sweet. Okay. Does arc cosine have any symmetry, even, odd, or neither? It has y-axis symmetry. You can fold that on the y-axis and the graph would perfectly line up with itself. No, it doesn't have y-axis. It doesn't have origin, so it has neither symmetry. It's neither even nor odd. So it really has no symmetry. No symmetry. If we took that graph and shifted it downwards, which then would not be the graph of inverse cosine, it would be a transform graph, then that one would have origin symmetry. If we shifted it down pi halves, yeah. But the graph of arc cosine itself does not. Okay, let us try it out. Letter A, and again, I'm not using capital letters because now we're implying unless there is a specified interval for theta, we're assuming it's the function, even if it's lowercase. So inverse cosine of the square root of 3/2 should be pi 6. Why not 7 pi 6? What's cosine of 7? Oh, I'm sorry, 11 pi 6. My bad. What's cosine of 11 pi 6? Cosine of 11 pi 6 is square root of 3 over 2. So why is the inverse cosine of square root of 3 over 2 not 11 pi 6? Dang! Manayo! Yo! Way to go. It's in quadrant 4, which is out of the PVR. Good. Letter B. Arc cosine of negative 1/2. Two pi thirds or negative pi thirds? Bless you. 2 pi thirds or negative pi thirds? 2 pi thirds. Yeah. Very good. Very good. It's arc cosine. Cosine is negative, first of all, right? In the same quadrants it always has been. Quadrants 2 or quadrants 3. Quadrant 3 is outside the PVR. It's too far away from the positive x-axis, that quadrant 3. So it's going to be in quadrant 2. And, of course, it's your pi thirds reference angle. So it's 2 pi thirds. The arc sine of negative 1/2 would be your quadrant 4 angle. It would be negative pi 6. All right, inverse cosine of O, or 0. 0. Pi halves? Good, because cosine of pi halves is 0. Arc cosine of 5/7. Is 5/7 an angle or a ratio in this context? It's a ratio. Is it a legal ratio? Is it legal? To be legal, it just has to be between -1 and 1. Is 5/7 between negative? It is. It is. Okay. Is 5/7 on the unit circle? No, it's not. But I do know that this will give me an angle that will live in quadrant what? 5/7 is positive, so it's got to be some quadrant 1 angle. It's got to be some quadrant 1 angle. Now, if we don't know what it is from the unit circle, this would be a question that I would at least ask you, in what quadrant would the angle live? And you would say quadrant 1. But if I expected you to do any better than that, then you would go to the calculator. So let's go to degrees, because we still have a better understanding in decimals where degrees live rather than radians. So how would I type in arc cosine of 5/7? Do I go alpha A, alpha R, alpha C? No, I don't. I hit second cosine, good, of 5/7. And we should end up with an angle that's positive between 0 and 90. 44. That's pretty much what I thought it was. 44.415. So you would write that down and still lose a point. Degrees. Right. Sweet. Okay, so let's go to the next box. Again, not donuts, not pizza, but probably something just as delicious. Same thing we did for the sine and inverse sine and sine. Whenever you compose cosine and inverse cosine back to back in either direction, because they're inverses, they will undo each other, but there, of course, are qualifying qualifications. That's a great adjective for qualification. Qualifying. Cosine of arc cosine of x. This x here represents a what? A ratio. So, again, like with arc sine, if it is a legal ratio, it's always just going to be that ratio. What are the legal ratios? -1 to 1. The reason being is because when you take the arc cosine of that ratio, it's going to give you an angle that happens to be in the PVR. But the cosine of that angle will always give you the exact same ratio. So that one's a little safer. If you start with the ratio and end with the ratio, as long as it's in the domain of arc cosine, it's going to be that answer. It's when you start with an angle that you have to be a little bit careful, right? Because angles have to live in PVRs. So the arc cosine of cosine of x, where x is an angle, is only x to begin with if we start with an angle that's in the PVR for arc cosine, which is 0 to pi, sun on the horizon. Again, if we start with an angle that's not in the PVR, the answer will not be DNE. Rather, we have to figure out what is the angle in the PVR that has the same cosine as the given one. And that makes it more fun. So here we go. Inverse cosine of 3 pi fourths. Is it good? No, no? Yes, yes. Yes or yes, yes? Yes, yes. Yes, yes. Or heck yeah. to speak with a foul mouth. Heck yeah. Sometimes you just feel like saying that. Heck yeah. Because 3 pi fourths lives in quadrant what? 2. Right. Now, in this case, you could just work it out. What is cosine of 3 pi fourths? Negative square root of 2 over 2. And then the inverse cosine of negative square root of 2 over 2 has to be in quadrant 2, so on the horizon, not quadrant 3, quadrant 2, and that would be 3 pi fourths. But it's helpful to know when they just cancel out in the event that we can't evaluate cosine of the given angle. Arc cosine of 7 pi 6. D and E, that would be an answer choice. So it's 7 pi 6. Both of those, unfortunately, are not as correct as the correct answer. So you get like 0.3 points for that, and I would then round. Partial credit, but then we round. If it's less than 1, it rounds down to 0. Why is it not 7 pi 6? Because 7 pi 6 is in quadrant 3, right? And is quadrant 3 the sun on the horizon? No, it's not. It's like the sun underground. Well, it doesn't make sense. Okay, it doesn't actually go underground, guys. It just kind of disappears around the planet Earth. Right? Yeah. Right. So you could work this one out, but let's not. Let's do it this way. 7 pi 6 is over here. What is the reference angle? Pi 6. Good. In that quadrant, which is 3, cosine is positive or negative? Negative. What's the other quadrant where cosine is negative? Cosine is also negative in quadrant 2. That's the one of the PVR. So it's going to have the exact same reference angle, pi 6. So now you're asking yourself, what is the angle in quadrant 2 with the reference angle of 1 pi 6? And of course the answer is 5 pi 6. Yeah. I didn't make you stress. I made you memorize it. You chose to stress. Okay? I didn't stress at all. It was actually quite enjoyable to me, soothing, the unit circle. But I was insistent that you learn it. Okay. Inverse cosine of square root of 2 over 2. It's inverse cosine of cosine. Those are inverses. So there's a possibility that they simply undo each other, and we just left with what we started with. Is square root of 2 over 2 an angle or a ratio? Good. It's an angle. At this point, it's an angle. How do we know it's an angle? It follows cosine. Now, square root of 2 over 2 is a good-looking ratio, right? It's the ratio at pi fourths. But in this context, because it follows a cosine, it's an angle. It's just a number. What is the square root of 2 over 2? Does it happen to live in the PVR of arc cosine, which is 1 or 2? I think so, because the square root of 2 is like 1 point something. Divided by 2, that's going to be a positive number that's less than 1. And a positive number less than 1 is in quadrant what? 1. Yeah. So, does this just undo itself? It does. Yes, it does, indeed. Whew. We're getting more fun. We call this Fun Friday. Okay. All right, this is an angle. Yeah. And remember, as long as we're starting with an angle x that happens to be between 0 and pi, we're good. Well, in decimals, that's 0 and 3.14159, blah, blah. Square root of 2 over 2 is just some small positive number that's actually between 0 and 1. And so it's a legal angle, and so it's just going to be what we started with. Yeah. All right, cosine of, arc cosine of, negative 0.5. Is negative 0.5 an angle or a ratio? It's a ratio. Is it a legal ratio? What are the legal ratios? Between negative 1 and 1. Is that between negative 1 and 1? Heck yeah. It's cosine of arc cosine, so it's just the same thing we started with. Yeah. Now, just for kicks and giggles, we could actually work it out from the inside out if we were in doubt, but we're not. But we do have a little bit of extra time because Saturday's not here yet. What is arc cosine of negative 1/2? Yeah, 2 pi thirds. Good. Remember, if you take an inverse cosine, you're not going to end up with a negative angle. That's only for arc sine, and as you'll see later, arc tangent. Arc cosine, if it's a negative number, you're going to get a positive of 2. So it would be 2 pi thirds. So what's cosine of 2 pi thirds? Negative 1/2. So you could work this one from the inside out, but the goal is to not. Like on this one here. Inverse cosine of 23 pi 7. Inverse cosine of cosine, they're inverses, so this would be an answer choice. Is it the right one? No. Is D and E correct? That would also be an answer choice. No. So this one is not going to be 23 pi 7. It's in the domain of cosine, so it's going to work. But 23 pi 7 is not in the PVR of arc cosine. Okay? So just like before, we have to figure out where 23 pi 7 lives. So remember to do that. Over here would be pi, which is 7 pi 7. Yeah. So if you want to count, this would be 3.5 pi 7. So you're counting every time you go to another quadrantal axis, you're counting by another 3.5. So this would be 10.5 pi 7, and all the way around would be 14 pi 7. And if you went again, 14 plus 3.5, or 14 plus 7, 14 plus 7 will be 21. So over here we're at 21 pi 7. And then another 3.5 is going to put us over here. So we do terminate in quadrant what? Quadrant 3. And what's the reference angle if 21 pi 7 is the negative x-axis and we went past it to 23 pi 7? Yeah, the reference angle good is 2 pi 7. So you do need to find the reference angles. Now remember, for sine, you mentioned it's always going to be plus or minus the reference angle. Not so for cosine. So in this quadrant, quadrant 3 is cosine positive or negative? Negative. What is the other quadrant where cosine's negative? 2, and that's the one in the PVR. So the angle that I want, why did I undo it? I just did it. Okay, because I hit the wrong thing. The other one I want is going to be the angle that lives in quadrant 2 that also has a reference angle of 2 pi 7. Good. I'm stopping 2 pi 7 short of 7 pi 7. So 7 pi 7 minus 2 pi 7 is 5 pi 7. I like these types of questions. No. I don't know. He's the math mascot. I would be like this. Yeah. That's me. Oh, and then the microphone. Yeah. Oh, I also have eyebrows and ears. Yeah, and maybe a bow tie with a bolo tie on it. Yeah, that's me. So if I ever draw that, that's me. Yeah. I don't know. Don't ask me. I was lost in an artistic moment interpretation. Yeah. Okay, sweet. So this is a good question right here. We've culminated so far in this section with this problem right here. Any comments or questions? What does culminate mean? Misculminate. Is that even a word? I don't think so. I miss Coleman too. Hi, Coleman, if you're watching. All right, example 10. Draw a couple of cycles of tangent. All right, so we're going to meet arctangent now. Arctangent. Yes. If there's 6 trig functions, how many inverse trig functions are there? 6. This is number 3. Yeah. It's fun to learn. Pi halves. Negative pi halves. And then it does it again. And we got 3 pi halves over here. Better write small. And negative 3 pi halves. So on and so forth. Yada, yada, yada. Blah, blah, blah. Okay. Oh, by the way, let's write it out here. F of x. This is tangent of x. Is tangent 1 to 1? It is not, actually. Any 1-to-1 function passes the what? The horizontal forearm test. Does this one pass the horizontal forearm test? No. Okay? It touches here, touches there, touches everywhere, right? Yeah, this graph would touch the horizontal line instantly many times, so yeah, it fails as badly as sine and cosine. So there is hope, though, like there was for sine and cosine. We want to restrict the domain of tangent to a convenient 1-to-1 interval that has all the values of tangent, which are from negative infinity to infinity. Pi halves to 3 pi halves? 7 pi halves to 9 pi halves would work. Not very convenient. Yeah. The most convenient interval is going to be, like sine, the symmetrical interval on either side of the origin, negative pi halves to pi halves. We can't include pi halves and negative pi halves in this case because they're the vertical asymptotes, right? Okay? But if I take that branch that lives between the vertical asymptotes, I get a 1-to-1 interval, passes the horizontal line test, and it does include all the tangent values from negative infinity to infinity, and it is convenient by the criteria that it is the one that passes through the origin, okay? So we're going to restrict that, and if I reflect that across the line y equals x, I'm not going to do that low-tech paper model anymore. I think you can kind of imagine what it looked like. What happens to the vertical asymptotes when we reflect them across the line y equals x? They make horizontal asymptotes. So we'll have a horizontal asymptote up here at y equals pi halves instead of x equals. And then symmetrically, we'll have one down here at y equals negative pi halves. And then it's going to look like this. The graph of inverse tangent looks like that. And this is, believe it or not, the only inverse trig function graph that you have to memorize. You still have to know the PVRs of them, okay? Half moon, sun on the horizon. But this is the only one whose graph I want you to memorize. Of course, inverse tangent works, but we can also equivalently call it what? Arctangent of x. Yeah. So let's list some things here. The domain now of arctangent is what? All real numbers. And that used to be the range of tangent. So that one is very different because this one now does have end behavior. Watch this. What is the limit as x goes to infinity now of arctangent or inverse tangent? It approaches pi halves. If you hop on this graph and you head out to the right, you get closer and closer to pi halves. What would be the limit as x goes to negative infinity? It approaches negative pi halves. So this is the only inverse trig function that you're responsible for that has a domain of all real numbers and that has end behavior. Those two limits right there are very, very important if you go on to take calculus. Okay? They show up a lot when we work with improper integrals and when we evaluate limits in evaluating those improper integrals. Very important. Okay? What is the range, or the PVR? We'll call it the PV, principal value range. Again, principal implying that there's more than one, but this is the most important or most convenient. Negative pi halves, good, to pi halves. Inclusive or non-inclusive? Non-inclusive. So aside from the endpoints, it's the exact same PVR as which one we've already seen? Arc or inverse sine. Sine, right? Remember sine was negative pi to pi halves? So if you're going to do this one with the unit circle, it is the half moon again. The only difference is you have to put open circles on the y-axis instead of solid dots. But it's the same pretty much as arc sine. So if you ever take the inverse tangent of a positive ratio, you're going to get a positive acute angle. And if you take the inverse tangent of a negative ratio, you're going to get a negative acute angle. A negative acute angle. I don't think they're allowed in heaven, right? All angels have to be positive. A negative acute angle. Good. Any symmetry going on with this one? Even, odd, or neither? It has origin symmetry. Yeah. I hate when I write with a highlighter. Origin symmetry. So it's an odd function. So that means that inverse tangent of negative x is the same as what? Do I get rid of the negative input or bring it out front? Bring it out front. It's the same as negative inverse tangent of positive x. So arc sine and arc tangent are both odd functions. Arc cosine is neither. Trick question. Cosine is even, but arc cosine, remember we just saw, had no symmetry. All right, so memorize this graph. It's still a monotonic increasing function just like tangent was, but it's curved differently. This one comes in concave up like a cup and then becomes concave down like a frown, where tangent comes in concave down like a frown and then becomes concave up like a cup. All right? So there's a graph of arc tangent. Blah, blah, blah. Example 11. Inverse tangent of 1. Is 1 an angle or a ratio? It follows an inverse, so it's a ratio. Is it a legal ratio? What are the legal ratios for tangent? Anything. What is the domain for inverse tangent? All real numbers. All real numbers. Is 1 real? Oh, it's real, y'all. 1 is real. It's real lonely, supposedly. 1 is the loneliest number. So, but not all who wander are lost. And not all who are alone are lonely. So, what is the answer? Shut me up. 0 is wrong. Pi fourth is right. Why is inverse tangent of 1 pi fourths? Because what is tangent of pi fourths? 1. Good. Now, what is tangent of 5 pi fourths? What? Wait, what? Wait. Tangent of 5 pi fourths. Quadrant what? 3. Negative x, negative y. So tangent of 5 pi fourths is also 1. But why then is the inverse tangent of 1 not 5 pi fourths? Not in the PVR. Good. Not in the PVR. Arc tangent of negative square root of 3 over 3. What the? What quadrant is it going to be in, first of all, if it's a negative?
Well, it has to be 1 or 2 or 4 because you have to not have matching signs.
1 or 4. Right? We're taking the arc tangent of a legal ratio. It has to be in the PVR, which is either 1 or 4, just like arc sine. So if we start with a negative ratio, we're going to end with a negative acute angle in quadrant 4. So the answer is going to be negative something, and it is pi 6. Very good. Good. Because what is tangent of negative pi 6? Well, it's the same as tangent of 11 pi 6. And I quizzed you over tangent of 11 pi 6. It's negative square root of 3 over 3. Now, how do you know that if you forgot? You have to deconstruct this. Square root of 3 over 3 is what happened after you rationalized negative 1 over the square root of 3, right? So that is it unrationalized. Remember, when you do tangents on the unit circle, the 1/2s divide out. So that's what it used to be before the 2's divided out in the denominator, and tangent is y over x. So now, what's your ordered pair whose x is square root of 3/2 and y is 1/2? Your pi 6. Good. So you know it's your pi 6 reference angle in quadrant 4 that you get to by going down clockwise. All right. What is inverse tangent of 0, Tyler? Yeah, 0. Inverse tangent of that number is what? Yes, this is a 0. Very good. Inverse tangent of, say it with me now, 0 is equal to what number, though? Zero. Yeah. It's 0. What? Couple of reasons. First of all, you could check. The inverse tangent of the ratio 0 is the angle 0 because what is tangent of the angle 0? 0. Yeah, or look at the graph of tangent, inverse tangent. It passes through what point? Known as the origin. 0, comma, 0. All right, one last one to take us to the weekend. Arctangent of 30. Is that an angle or a ratio, 30? It's a ratio. Is it a legal ratio? Yes, because it's part of the real numbers. It's going to be 88.090 degrees. And we need the last 0 because it's part of the accuracy. Have a fantastic weekend. We'll finish this section on Monday. So the worksheet will be due on Tuesday.